Hi, Sam here from Roberts Geospatial. In this series of videos, we're going to use ProRaster Scientific to map the changes in vegetation over a period of an entire year at a large outback cattle station in Australia called Coorabulka. So we're going to acquire Landsat data over a period of a year. We're going to import that data into ProRaster Scientific. And you can see that data rendering in the background now. We're going to build products, and we're going to take a deep dive into building mosaics, using collation to improve your coverage, and building sequences like the one that we're seeing now. We're going to use the ProRaster Scientific product editor to compute vegetation indices and compute statistics. And the animation that you're looking at now in the background shows you the Normalised Difference Vegetation Index as measured over Coorabulka Station over that period of time, over that year. And the events that we're going to see are local rainfall, and also we're going to see flood events coming down through the Channel Country on the western edge of the station. And all of those events are going to have impacts on the vegetation coverage at the station, and we're going to measure that quantitatively. We're going to finally we're going to take that data into a spreadsheet, and we're going to analyze all the statistics. We're going to look at how they change, and eventually compute a vegetation biomass proxy. So for example, we have here valid cell count for mosaics and collated mosaics, and we'll explain all this, looking at minimum and maximum values in our vegetation index over time, the mean, the median and the mode and what they mean. We're going to look at our quartiles, lower quartile and upper quartile and the median, and see what they mean, the standard deviation. We'll look at skewness, and we'll build a vegetation biomass proxy and examine that process. So just before we get started, a note on the hardware. You'll notice I'm using Windows 10. I've moved to my old Windows 10 machine because the laptop is full up, and this particular study requires quite a lot of space for the Landsat data. So I'm using my old Skull Canyon NUC. It has I think it's a 6th generation Intel quad-core CPU in it, so it's quite slow compared to a modern laptop, but it does have 32 gigabytes of RAM, which is good, and it's got a 4 terabyte SSD, which is what I need for this particular study. So let me show you where Coorabulka Station is. Just bring up Google Maps in ProRaster. So here's Australia, here's Queensland. The station's located out here in western Queensland. So we have the Diamantina River flowing down here in the east, and we have the Georgina flowing down here in the west, and the station is sandwiched in between them. So this is what's called the Channel Country, and the area is prone to intermittent flooding. So according to Wikipedia, the station is, and I'm just reading from my notes here, 6,370 square kilometres and carries up to 8,000 head of cattle. So I found a polygon for the station on a Queensland government website. Now, it doesn't seem to be quite up to date because it's only 4,854 square kilometres. So we're missing part of the station in this study, but really that doesn't matter for the purposes of this video. And just for clarity, I don't have any relationship with Coorabulka Station, and I've never visited. I just chose it because it's a large cattle station. It's spread over 2 different Landsat scenes, which means we'll be using mosaicing, and it's in an interesting location. So of course I have prepared all this data in advance, but we'll we'll go ahead and make some of it again. So I've already got a Coorabulka scene database into which I've placed all of my Landsat scenes, and I've also got a Coorabulka product database in which I've already prepared all the products. So let's take a look at the data. So here we are in Coorabulka. So we have 98 Landsat scenes in this directory, and inside each one of these scenes you'll find all of the TIFF files for each of the bands. So we've got the complete scene, we have all the data. So let's bring that into a scene database. So we'll go to our Browse Scenes button, say Add Scenes to a new database by folder search, and this will be my I'll call this Demo Coorabulka. Hit OK, and I can now browse to my scenes. So in my data directory, MSS Coorabulka, here's all my directories. Just select this folder that is grouping all of these Landsat folders. So there you go, it's finding all of those 98 scenes, and now it's registering them all and writing an entry into the scene database for each one of those scenes. So you can see that here's our scenes. There are two different tiles, row 98, path 98 and row 76 and 77, and we've acquired these two tiles at 49 different time points. So our first acquisition here is 2022 on the 9th of July, and our last acquisition here is 2023 on the 28th of July. So we've got a period of just over an entire year. So over the period of that year, and let me just make another point, we've picked up both Landsat 8 and Landsat 9 satellite scenes. So we've got about an 8-day revisit period. So over just over, say, well, we're about 380 days. So we've got 49 revisits over that period. So just a few other points to note here. So firstly, we've downloaded Landsat Collection 2. We've downloaded the Level 1 product, which is the top of atmosphere data. We haven't downloaded the Level 2 surface reflectance data. So with the Level 1 product, we've got pan sharpening available and so forth. Looking down here at the instrument, if I sort by instrument, you'll see that most of them are recording OLI tiers. That's standard. But then, there's one here that just has OLI. So for this particular scene, they've turned off the thermal camera for some reason. So this can happen, and you just need to look out for it. It does happen from time to time. Also, let me select columns here, and I'll put the tier and the processing level in. And let's just have a look here. So in our tier, some of them are real time, some of them are tier 1, and some of them are tier 2, so there's a real mixture there. And in our processing, you can see that most of it is L1 TP, which is what you want, but some of it's L1 GT, so we've acquired that data before they've finalized the final processing. So let's just go ahead and render some of this data and see what it looks like. So I can say, I'll right click on this first scene and say render scene. We have top of atmosphere reflectance, so that's what we'll be using. We can choose any band combination. We'll choose natural color with atmospheric removal. And we have pan sharpening available to us, and we can also mask, but I won't mask in this case. So there's our scene. You can see the Georgina River coming down here, and here's the Diamantina. Let's go ahead and add this second scene. So render scene to layer. We're building a mosaic effectively here. Turn on pan sharpening. And that adds that second scene, which is we've gone from row 76 to row 77. And we now have our two scenes in a simple mosaic. And you can zoom in and see the complexity that exists in this channel country. Thousands and thousands of tiny little channels in which a very flat country, of course, that the water flows down, and when it does come down, when it produces a flood, of course the vegetation responds, and that's what we're going to be trying to measure in this study. So there's just a simple rendering of it. Let's now go ahead and make a mosaic product.